Still can't hear anything.
Can you all hear me now?
Now we can hear you.
Sorry about that, operator error. Thank you very much for your patience. Okay, welcome to the RIST roadmap. What's next? I want this to be interactive. Now that the audio is working, you can stop me and ask questions instead of just me talking at you. So let's get going. Our agenda for today is who's behind RIST, just introduction, right? We always do that just in case. We'll do a quick review of what's out there, RIST Simple Main and Advanced Profiles, and then we'll get to the meat of this, the RIST roadmap. And then I'm hoping to elicit some questions and a good discussion. So who's behind RIST? I've shown this slide many times if you've been to these presentations. There's two organizations involved. One is the Video Services Forum, and the RIST Activity Group is in the context of the Video Services Forum. Those are the people who actually meet, decide, do the technical work. Those are the technical people, and that group is chaired by Rick Ackerman, who is also here in the webinar. That group produces the RIST specifications, which go to the Video Services Forum board for approval. And there's the RIST Forum, which is the marketing education organization that helps to bring the message out there. I'm a member of the RIST-AG, and I'm the president of the RIST Forum, so it's that stage. I asked Susanna, our chairperson, on Sunday, on December 3rd, how many people we had, and there's 222 people or members in the RIST Forum at the moment. This is just a sampling. We need to redo this slide, but you can't fit 222 anymore into a single slide. So it's growing. All right. Introductions out of the way. Let's talk about RIST Simple Main and Advanced Profiles. All right. Milestones and acknowledgements to Wes Simpson for doing this slide. The RIST-AG was formed in February of 17 during VidTrans, but we didn't actually do anything until NAB in 2017. So we worked on it for a year, and we had the first successful interop demonstration in September 2018. There was an earlier one, but it wasn't open. RIST Simple Profile came out on October of 18. Main Profile came out in March of 2020, and Advanced Profile was published about a year ago in October of 2021. So those are the major milestones. So what is this business of Simple Main and Advanced Profile? Some of you who've been in these presentations probably know this, but let me go into, just give a primer, right? Simple Profile gives you packet recovery to ARQ. So that's the basic reliability. And also gives you multi-link operation to bonding or seamless switching. Main Profile gives you flexible networking with tunneling and in-band data multiplexing, and gives you the important part of security. So there's no two security modes. One uses a standard BPLS, which is certificate-based, or PSK. And there are multiple authentication options, including a brand new PSK authentication. So that's simple and main profile. Advanced profile is another funnel that allows the ability to run any protocol over RIST. So you now have basically a protected VPN with advanced profile with enhanced security and payload identification. So if you want to know more about advanced profile, we have I have presentations. There's stuff out there. We're not going to talk about this today because advanced profile is now in the rear mirror. It's done. All right. Where do I find more information about that if I want to read about it? Simple Profile is TR-61. The latest version is 2020. So it was first published in 2018. It was revised in 2020. The 2020 revision just added something called the RTT echo message to measure RTT. The main profile was first published in 2020 after a very successful interop in LA. Was revised in 2021 because we had a security problem. And there was a major revision in 2022 that added the VSF ether type and also added a big chapter on PSK authentication, which is also coming out as an RFC. It's now an internet draft, that section of TR-62. Advanced Profile was published in 2021 and was revised in 2022, and the revision was simply to include the same PSK authentication as main profile. One thing I love about this is all RIST specifications are available free of charge from the VSF site. So it is an open specification thing. You can go there and get all those specifications. So again, this is what's in the rear view mirror. So now let's get to the meat of this webinar. What's next for RIST? What are we doing? Aren't you done? What are you guys still doing in the AG? No, we aren't done. So what are we working on? The major features of RIST are essentially complete. So the market has adopted main profile. So there's simple profile, main profile. Main profile is kind of the main line right now. And we expect to see RIST Advanced Profile solutions next year. Now the RIST-AG is working on ancillary features, which will be published as TR-64. So if you recall, TR-61 is simple, TR-62 is main, TR-63 is advanced, and TR-64 is ancillary features, and there will be multiple TR-64 parts. So, roadmap overview, near term. TR-64 Part 1, Source Adaptation, and I will talk about in detail about a number of those. This was just published, Source Adaptation. It was just published, so you can go get it already. TR-64 Part 2, use of WireGuard, VPN in RIST devices. This is complete. It's under review. Just yesterday, we got the VSF comments on it. And this should come out, I don't know, I can speak for the VSF board, and there's Christmas and everything, probably early next year. TR-6 Part 3, RIST Relay. The AG has actually completed all the technical work, and it's in the writing queue, which means I got to write that once I have time. TR-6 Part 4, receiver synchronization. It's still the same. It's the same status. We finished the technical work. It is in the writing queue, which means I got to write it when I have time. So it goes through a process. It gets written, and gets approved, gets discussed, and then it gets published. So you should see Part 2 come out maybe in January, Part 3 a few weeks later, and Part 4 just like after that. And now what we're working on right now, TR-64 Part 5, risk management and control. The work has started, but we've actually made has done a lot of work on that, but it's nowhere near complete. We're still thinking about that. So that's the short-term stuff. What's planned beyond the short-term stuff? So Part 6 should be congestion control, which we may fold into risk control. So this may not be its own part. Part 7 is automatic configuration, which we may also fold into risk control. We're not sure, so that's not guaranteed. There will be a part 6 and a part 7. And part 8 is internet satellite hybrid model, which is something that is becoming more and more necessary with all this 5G stuff. I'm saying work will start in the next few weeks. It's actually started. We defined the problem, but we haven't. We just basically defined the problem. We haven't moved into solution space yet. Part 9 is the RIST-AG listener. We haven't done anything about that yet, but it's in the queue to be worked on. It's important to say that there's no guarantee that any of the above items will actually happen. So that's my disclaimer there. All right, so let's get into the stuff that's done. Ciro 6.4 part 1, source adaptation. So what's our motivation to have done that? Well, a basic function of RIST is packet loss recovery to retransmission. However, if you don't have network capacity, there's no retransmission, no fix it. You cannot make a 5 megabit stream going to 4 megabit per second. There's no retransmission in the world or PEC or anything else that can fix that. So you need to resolve that at the source. So source adaptation. One thing you can do is to reduce the stream bit rate. So, and that's not novel. All the multi-link cell bonding things do that. You got to control that encoder if you can. Or if you have multiple links, you can reroute, which is also a very good thing you can do. In fact, that's the first thing you should do if you have the ability before you try to go reducing the bit rate. All right. So what's the protocol fit? So what the AG has done is link quality extensions. It's a protocol for the receiver to report to some RIST device what the quality of the link is, basically how much packet loss you're getting and whether you're having uncorrected losses or not. It's possible, it would have been possible to define another protocol, which is a gateway to encoder protocol, but we decided in the AG not to specify that protocol because it would be applicable just to legacy devices, and a legacy device will probably not implement another protocol anyway. So the encoder control protocol is not part of the TR. And if you're in the business of making RIST gateways that talk to encoders, you've got to talk to that encoder vendor and have them disclose their protocol. Many encoders do have some protocol to do that. And the behavior of the encoder is also varies from encoder to encoder, basically how fast it reacts to a command. So the AG simply provided the link quality messages, and the device is going to have to adapt to that. So what is and isn't in the TR, which you can now read because it's published. What is in there? A method for receivers to periodically report statistics and support for global and per-link statistics. So if you have multiple links, you want individual link statistics so you can make informed decisions about that. What's not in the Ciro 6.4 part 1 is the encoder control protocol. As I said, there's no need to specify. We decided to not specify this. And the actual algorithm to decide when and how to increase or decrease the source bit rate or modify the route. We provided an example, but we didn't specify the protocol, just the same as MPEG specifies the decoder, and you are free to, as long as you generate something that complies with the decoder, you can encode any way you want, and you can be inventor. So we didn't move into that protocol. You just do the protocol you want. You can be smart or as smart as you want. I'm not going to say the opposite. You can be as smart as you want in there in providing a protocol. And you should be aware that different companies may have IPR on that. So be careful what you do there. All right. Ciro 6.4 part 1 operation. The receiver periodically sends link quality messages back. The message frequency is up to receiver and may be variable because if your network is changing often, you're going to send those messages more often. If the network is stable, you don't have to send these messages very often. And those messages have sequence numbers and are protected for transmission. And we don't timestamp them because you don't want stale information. Send them as soon as possible, react on them as soon as possible, and that's that. And there are global and specific versions of the message. Only RIST Advanced Profile has the link specific messages. Okay. I'm not going to go talk about protocols here because this thing is done. I just telling you what it does, and then if you're interested in the details, go download it and look at it. I also have a presentation on the internet about that. So one important thing, people think about the encoded adaptation, but one important thing that we did is multi-link application. So you may have multiple incoming links with the string spread over these links, either bonded or replicated. So you send in STR-64 part 1, you send identical copies of the global link quality reports, and then you can send link specific per link immediately after the global version. So, but only if you have advanced profile. So here's an example and acknowledgements to Adi Rosenberg from Overlinks from putting that together for us. This is actually in the PR. I copied that from there. The sender has 3 links. And we allocate 30%, 30%, and 40% on the links. Now, link A shows a 10% increase in packet loss. So receiver is saying that, okay, link A has gone downhill. So this informs the sender, and the sender says, maybe I will adjust that. I'm going to put 20% on link A, and the other 10% I will spread about link B and link C. So you don't have to necessarily decrease the encoder bit rate. You can adjust your bonding in this case. All right. That was that. That was enough of that. As I said, the STR is out. You can go download it and look at it. Next part is use of WireGuard VPN in RIST devices, the one we're working on right now. What's our motivation for that? Main profile defines a tunnel with optional encryption and security. So what's a tunnel with security and encryption? That's a VPN. So why not use an off-the-shelf VPN? And we actually debated that in the AG. And off-the-shelf VPN was always an option. So we decided to have an off-the-shelf VPN to make sure that you can actually interoperate. So if you're going to pick an off-the-shelf VPN, we suggest you pick this one, and we picked a WireGuard. So what we're doing here is suggesting a WireGuard configuration so that if 2 RIST vendors implement WireGuard, you have a higher chance of them interoperating because they use a common set of parameters. So what's that? We're assuming a star configuration, multiple clients connected to a server, possibly with redundancy. WireGuard supports that. Configuration files are centrally created and pushed to clients through out-of-band means. Both IPv4 and IPv6 are supported. And we have higher security with pre-shared symmetric key recommended. And there are no routing restrictions on server and client. This is, if you're doing that, you use it to transport simple and advanced profile traffic, as well as in-band generic traffic. Another cool thing about this is that the configuration file from the client is small enough that you can use a QR code for that. It fits in a QR code. So here's an example of a configuration file, and voila, you have a QR code. And that is in the TR, a method to convert the client configuration to QR code for clients to support that. It has to be something that can read the QR code. It will be typically a cell phone, but I'm not allowed to say the word standardized, so we specify that. All right. Next part 3, RIST relay. What's the motivation? We have a RIST client, a RIST server behind firewalls. Everything's behind firewalls. The client wants to connect to the server, and The firewall on the client side is not a problem. It's an outgoing connection. The firewall on the server side will not let the connection in because that's what firewall is for. So we need an IT department to open and forward one more port for this to happen. That's the bane of our existence. You gotta go call some IT department, open a port for that this stuff to work. All right. Can we make this work without having to involve IT, just like Skype? We want Skype. We want something that just works. So what's the generic solution? You need some sort of server to help that communication, publicly accessible server to help that the clients communicate. What is that? The RIST relay, the RR, RIST relay. Well, the first question we can ask, why not stun, turn, and ice? There's protocols for that, aren't there? Okay, so there's RFCs to support that. What's wrong with that? Those are not complete solutions. You see here a long list of problems. Stun allows the node to figure its public address. Okay, it's part of the problem, but not all. Turn is a relay server. ICE is a means to negotiate that, but you still need something like a SIP server so nodes can discover each other. And there are possible security issues. I'm not going to get into that, but you can look in the internet. So for the security, it is necessary to combine all the functions into a single server. And that is what we decided to do in the RIST-AG. We have good security. We use good security and design a complete solution using advanced profile. Firewall implications. There's something called symmetric and asymmetric firewalls. And asymmetric firewalls is probably what you have in your home. Allows the bottom line for that is endpoints can connect directly. So you can use a server to manage this or to get you started, but then you can talk directly. So those are low security firewalls. That's the stuff you have at home. But corporate environments have something called symmetric firewalls. So you can only connect to the server. So in order to work with symmetric firewalls, the server has to relay. So that's why we called it the RIST relay. When you do a Skype call, in most cases, you're talking directly to the other side. The Skype server just allowed you to connect. It created state in the firewalls, and then you write that state in the firewall. But you need to be able to relay. So if you're doing a generic solution, you need to be able to relay. And that's why we call it the RIST relay. So some requirements on that. You need to log in because you're going around the firewall. So security is important. You need to be registered. And since you can connect from anywhere, you need to have some sort of directory service. And bypass connections, when you connect directly, you need to be able to facilitate that. But there's no way to know. So if that's not going to work, you need to be able to forward. And you need to give endpoints some control of what happens. Security. So RIST relay is something that only works in advanced profile with encryption authentication. You can use DTLS. You can use DTLS with TLS SRP. You can use PSK. And you can use WireGuard, which is TR6 for part 2. So WireGuard with advanced profile riding on that. And the authentication information, which we done a lot of work in RIST for that, is what identifies the endpoint. And we added a human readable name so you can do that connection. So the RIST-AG has designed a whole protocol, which I'm not going to talk about. You're going to need to wait for the PR to come out to read about that. But it's an extension of RIST Advanced Profile control messages. The general operation is as follows. When you connect the endpoints, receive something like RR is ready, RR is busy, go away, or go talk to this other RR. Once you connect, you say, I wish to connect. I'm sitting here waiting to be contacted, or give me a directory list. Or I'm not ready to do anything. I'm just connecting just because I like to connect, but it's usually to be ready for some future thing. And when the endpoint asks to connect, it is told, here's how you connect to the other guy if you're going to go direct, or just use this relay itself for communication. That's the relay part of the RIST relay. All right. That's that. Decoder synchronization, and I'm going very fast, so we have time for questions at the end or discussion, which is will be very interesting. Decoder synchronization, what's that about? You have a whole bunch of encoders and a whole bunch of decoders, more than encoders, and some IP network. Oh, maybe the internet's an IP network connecting those encoders to these decoders. And the requirement is that frames of video that come to the encoders at the same time need to be played at the same time in the decoders. At the same time means between one frame time. So why you want to do something like that? Some sports production, you have a whole bunch of cameras, right? Soccer, World Cup, you probably won't have multiple cameras, and you're going to broadcast center, the cameras have to be synchronized. There's no question about it. They have to be synchronized. So that's one application. In some of these, you do that with very low latency, but we have to be synchronized. There got to be a method to do that. The other one, which is actually pretty common, is house of worship. When you have a main church and a remote church, and the service happens in the main church, and you have multiple cameras, multiple angles, and you have multiple screens at the remote church. And those have to be synchronized because when the pastor goes from one camera to the other, there can't be a lag. So there's actually multiple deployments like that. House of worship is an important case for synchronized decoding. So how RIST is doing that? It's pretty obvious. You need if you want to decode in synchronization, you need to make sure that the end-to-end delay is the same between all encoders and decoders. So you add some additional delay to make sure that everything lines up. So this is not really conducive for very low latency, because you're going to add latency. Basically, everybody needs to match the slowest person, the slowest link. So everybody has to align with that. So we make the end-to-end delay all the same. How do you do that in protocol? It happens that we already had the requirements. In simple profile, you don't need to even go to anything other than simple profile. This is a simple profile thing. Simple profile already has RTCP sender reports. Now, in TRL61, they're only used to keeping firewall state. So it was kind of an empty sender report. You could use an empty receiver report. The receivers didn't actually need to pass this thing. It's just there for the firewall. But the sender reports already contain appropriate fields that include information required for synchronization. So all we did was to use those fields and slightly redefine that. So we made a small backward compatible change to the meaning of the fields from RFC 3550. And if you know your RFC numbers, that's the RTP RFC. That's not new. We're not inventing reinventing the wheel here. This is the method that RTSP devices use to synchronize audio and video. They send separate RTP flows, one with audio, one with the video, and use those timestamps to synchronize that. Every RTSP camera out there is already doing this. So to prepare out here, Mr. Ackerman, our RIST-AG chairman, we use the Lego approach. We use whenever there's something out there that works, we use that already. Now, this one has been implemented, at least at Cobalt is. So I'm going to show you a test. There's a recording of this in the YouTube, but we took video with burning time code. We feed that to encode. It's the same video, but we're going to send that over the internet from California to Illinois to 2 decoders, and we throw them in a multi-viewer that has video capture capability. And decoder outputs are not shown up. So then you can compare the time code. And look at that. This is an actual capture from the multi-viewer. Now, I presented this this year at NABBEITC. So it's in the proceedings of technical paper. It's also in the Cobalt website. And this is also coming out in the Scientific Journal with some preliminary results there. and a very good description of the protocol, which you can get before the TR. And now we come to the interesting one, TR-64 Part 5, which is risk management and control. And I am not going to talk a lot about this because we haven't done a lot about it yet. Again, let's start with our motivation. Provide a common interface to allow these systems to hook up to a management system for status monitoring. See if anything is going wrong. Device configuration, release the automatic configuration, stream start stop, stream routing. Can I connect this guy to that guy? Automatic fault recovery. Now we want to use a modern protocol for this interface. So the word SNMP was uttered at one point and then immediately shut down. You need to, and obviously, since you're managing and you're looking, the interface must be secure from the ground up. It can't be oversight. So, what have we done about this so far? We start with something that my friend Adi calls a bucket list. We create a bucket and we throw all the requirements in the bucket. We have identified a few promising protocols, Yang, NetConf, RESTConf. And there's a key decision, design our own or make an extension of some existing control. We haven't decided that. We're looking at AMWA and NOS as an alternative. And we have not decided anything yet. Okay, so if you have opinions, you want to participate, you can join the RIST Forum. You can go to www.rist.tv and join the RIST Forum to participate in the marketing activities. Or if you can participate in the technical activity group, you need to be a member of the Video Services Forum, and you go to www.vsf.tv to apply. And I know I went through probably 44 slides in 35 minutes, which is a record for me, because I wanted to give you guys time to ask questions or make comments or discuss. Now it's your turn. What do you want to know? Don't be shy.
Ciro?
Go ahead, Adi.
Just one comment for everybody about the risk control. It is aimed to be working over the internet so that we can connect devices that are behind firewalls securely, reliably, from anywhere, from any location, from a moving targets. That is the aim of that protocol. Done.
Thank you, Adi. He's one of the guys who's leading that. Any other questions or comments?
So we would need to create an account somewhere, would we, to use that?
To want to create an account to use what?
Do we?
Go ahead.
Is that? Sorry. So is it we'd have to create an account somewhere to use these features and functions, or you don't need to do that?
Are you talking about risk control?
Yes.
It's all up in the air. What the AG is intending to do is come up with a protocol or an extension of existing protocol. The protocol will include proper authentication. And then what's going to eventually happen is there will be people who are going to make and market control systems, and they will have they will offer their authentication. There will be device people who hook up to this control system.
Oh, I see. Yeah.
Okay, but RIST-AG is not going to define that for you.
Yes, I see. Of course.
So there's a question here from John Hampton. What version of RIST is currently implemented in AWS? Is probably main profile, I believe. If someone can confirm, but I think it's main profile. But I may be wrong about that.
To be precise, AWS Media Connect support Simple Profile, Main Profile with DTLS encryption support.
Thank you, Eddie. See, I was right about that. Any more questions on discussion? It's your chance, man. All the experts are here. Oh, SRT versus RIST. We can talk about that a lot. Aji, you want to take that one? Or should I?
Well, we have High Vision here with us, but let's say like this. Right now, SRT is mainly focused on point-to-point connectivity. It is well maintained. Recently, SRT 1.5 was published. There are many applications using SRT like FFmpeg, VLC, and so. RIST is also is available for those applications by way of RIST, which is an open source library. The main difference comes in RIST's desire to be very professional and to provide professional level features. For example, bonding, load share, adaptivity, as Ciro pointed out, a lot of features that are very important when you deliver video and you have more than one connection, then RIST will shine. I'm hoping that SRT will catch up sooner than later. And we are going to publish a comparison blog under the RIST Forum in the coming weeks that is talking about that. But mainly that is the predominant differences, that SRT is using only one link, or maybe now you can have the option of having two links with the redundancy. With the RIST, you have that from day one, from the simple profile, using multiple links and using dynamic load share, and now you have adaptivity. Those features are not available to the best of my knowledge to everybody under the SRT package. They are available on with High Vision in their products. And
yeah, I would just add to that, Adi, that this is Mark from High Vision. I'm not as a technical expert like you for sure, but I would just say that, you know, first of all, a lot of our customers are using both RIST and SRT, and that it's true that SRT currently supports multiple paths for redundancy, not for bonding yet. So there are differences, and there are reasons why you might want to use SRT for one thing, and they might want to use RIST for something else, or you might want to use both. But you know, with a lot of the customers that we're talking to are looking at both RIST and SRT.
Thank you for that explanation. I can also point out that recently the VSF published a presentation of mine under the VSF channel that's showing how you can hook up SRT and RIST to enjoy both worlds. So then you can enjoy the bonding features while still maintaining your SRT connectivity. Maybe if somebody wants to touch base with me, I can share the link, but you can also find it on the YouTube in the VSF channel. And it explains how you can do that with open source tools and achieve that. It also includes sample codes to demonstrate that.
Okay. There's a question here. Since RIST and SRT are designed for unmanaged networks, is there any benefits of using this protocol with SD1? And you want to take that too, Adi?
Well, SD1 is basically a virtual private network that is provided as a software. Both SRT and RIST use UDP as the underlying protocol. Most SD1 do that. Some of them are using GRE or other protocols. The main advantage, in my view, is that if your SD1 allows you to use multicast, then RIST is multicast friendly more than SRT in that sense. So you can gain the benefit of using multicast with the RIST and having For the error correction, 2022-1 and 2, for the error correction with ARQ using multicast over an SD1 system that does support multicast. That is the biggest advantage that you can gain out of that.
Thank you. You can always use RIST. You can always have the packet loss support and the multiplexing and everything. You may be able to benefit from that.
Basically, when you have SD1, you may want to, the simple profile it should be enough because the security aspects is handled by the SD1 controllers and the network. But if you desire more security, can you apply DTLS, PSK features and all. SRT will allow you to do that, but it will be in a unicast fashion because SRT is fine-tuned more for the internet experience, and then it is unicast in nature.
Yeah, I would agree that SRT used over, WANs or LANs or SD-WAN is for most of the customers that are using it in unicast mode. That's true.
All right. Good discussion. Any more questions?
If I may note something that probably slipped you, we did add the feature which is multicast authentication. It was published, I believe.
Yes.
And multicast authentication is an exciting new feature that was added by RIST. And it allows basically not only with multicast, to those who are familiar with multicast, you have clients that want to join a multicast. They have the IGMP method of joining a session, but there is no authentication. Who can join, or do you have the secret password? With RIST, we saw that as something which is needed specifically to the cloud environment, where multicast now becomes available with some commercial vendors that provide cloud. And we saw that as a requirement that came from the field, and we added that capability so that not only that you do IGMP, you would connect and we will authenticate you, and you create a secret session, secure session, so you can receive the multicast and it will be encrypted for you. So in fact, it becomes a replacement for DRM. So it becomes like an open source DRM, which is free to use, free specification, and go about doing that.
Thank you, Ajit. This is actually, yeah, I didn't get into that, but that's actually very powerful. We had even a press release about that. This is in Seattle 6 2022 version. Anybody can join multicast. IGMP is not allows anybody, but then we added the method by which you can get, if the multicast is by which you can get the key, because you can't prevent someone from joining, but you doesn't know the key, that doesn't matter. So it is very powerful.
QS?
Go S.
So if I may, when you implement the multicast authentication, it becomes very similar to the operational model used in satellite broadcasting today. Basically, anybody with a satellite dish can pick up signals from a geosynchronous satellite, but you can't do anything with them because they're all encrypted. That's the very definition of a multicast. So with the RIST multicast, what we do is each individual endpoint establishes a point-to-point session with the credential provider, gets its self authenticated. In other words, it's able to prove who it is, and that it's and the system decides whether or not that particular user is allowed to receive a specific broadcast. And then once the that end device is authenticated, then it gets a decryption key that it can use when it joins the multicast to decode the media and make it available to any downstream devices. So very, very similar to how a satellite system works today. Done.
Thank you, Wes. Yeah, we're very proud of that. And the method is being proposed as it's an internet draft as well, so it's all open. There's a question: will RIST Relay be available in a cloud marketplace? I hope so. As I said, we in the RIST-AG, we developed the technology, and now you all can make products and sell it for money. And then just put an acknowledgement about it for us. You want to say something, Adi?
I wanted to expand the topic about the advanced profile for people to understand the benefit of that. People need to understand that it's a revolutionary thing that we did. It's a self-healing tunnel. It's not like before it was specific for a stream. In Simple Profile, we took a stream, we provided ARQ, the jittering delivery, it was a stream basis. Then we added the security in the main profile. So now we have security for that, and we can run multiple stream back and forth. The advanced profile is a revolutionary new concept. The idea is that you don't need to protect your stream. The tunnel does that for you. The tunnel provides the ARQ, the jittering, prioritization of services, if you like to do that, for you. It can do bonding for you. You don't need to consider bonding. All you need to do is just push data through, receive that on the other side. You can push uncompressed data. You can push compressed data. It is 2110 friendly, compressed or uncompressed. You can put JPEG XS. You can push SRT through. You can push NDI at either direction. And we didn't stop there. We can push any type of data. It can be file-based, TCP, whatever you want. The tunnel itself will provide you the means for error recovery, sometimes even before the TCP will react. So then it will provide better TCP. And this is important. When it is important, when you try to deliver RTMP. If the tunnel provides you the error recovery before the RTMP, that the TCP nature of RTMP will not kick in. So we will have a better RTMP. So it's a marvelous new way to deliver content to the cloud, in the cloud, from the cloud, where the tunnel provider does the job for you. All you need to do is show up and push data through and receive data, regardless of what. So it's a novel concept that is not available in the traditional way we think. It's not available, and excuse me, Simple Profile, SRT, or even the commercial products like Zigzag. They are focusing on a stream-by-stream delivery. The advanced profile is to deliver whatever you want. You want to push IPv4, IPv6, jumbo frames, everything is available, everything should be supported, and it is covered by the specification. Moreover, you can even give clues to the other side on the nature of the data that you are providing. So you don't need to spend resources to do deep packet inspection to detect what it comes in. We added a registry that we can detect whether it's a EBU protocol, a SMPTE protocol. It's you can register you can develop a protocol and register that. You can provide auxiliary information about the stream that you are providing, so the other side will know what to do with that, what to capture, what is the name of the service, how much buffering they need to assign to it, if ever. It's a great piece of work done by experts. We spent a lot of time doing that, and I believe it's an amazing piece of technology that will push the industry forward.
Thank you. Yes. There's a question here. When you talk about RIST in transmitters like Gates Air, when you talk about implementing into exciters, well, you can go and get gateways in the market today and put it in front of transmitters. I am personally not aware of anyone that's got it in the transmitter itself, but there's nothing that prevents you. And I see the idea has unmuted. You want to make a comment?
Yeah, basically almost every new design, every new exciter is software-based, and most of them can host a Docker container or application. And most, whether you want to have RIST or something like that, you can get it as a Docker container and put that in your Exciter and receive your STLTP or whatever you want by way of RIST. So this is doable if you have a Docker container, or so you don't need to do a lot of software integration, implemented testing or so.
Yes. Nice thing about all of this is the basis of RIST is RTP already. So it's just a layer on top of RTP. Is there a Slack channel for RIST developers to access like SRT? Yes, you can go to the RIST Forum website, and there's a link there. All right, getting to the top of the hour. Any last questions or comments? Any last words from anybody from the AG?
We are constantly looking for participants. We are constantly looking for feedback from customers or field problems, just like hybrid satellite came from the field. If somebody, multicast came from the field, if somebody has a requirement, can approach us, say, this is what I have, can you guys deal with that? You have a bunch of experts, more than 12 to 15 industry experts working together, and the outcome is free specification for implementers to implement later on. So you can join the activity or reach out to anybody of us in the RIST forum, and we will deliver that information to the activity group.
Yes, thank you. So there's nothing else. Thank you for joining. And I'm sure that a copy of those slides will be made available to you. And thank you again for a very interesting discussion.
Thank you.
Thank you.
Take care.
Thank you.